Hey friends, we completed theory portion of third chapter. Now let's look into some numericals.
So let's start with the first question. The storage battery of a car has an EMF of 12 volt. If the internal resistance of the battery is 0.4 ohm, what is the maximum current that can be drawn from the battery? Okay, so here in the question we can understand that what are the things we have to find? We have to find the maximum current. We have to find the maximum current through the circuit or the maximum current drawn from the battery. That's what we have to find. So let's take the first question. The storage battery of a car has an EMF of 12 volt. So EMF is given, V is equal to 12 volt. That is good. Okay. Then what else we have? And if the internal resistance of the battery is 0.4 ohm, that means small r is also given 0.4 ohm. Okay. What is the maximum current? That is, we have to find I. We don't know I. Okay. This is a simple question based on Ohm's law. So by Ohm's law, we know that V is equal to IR. Here we are taking small r. Or we can write, we can substitute the values here. But we got 12 is equal to I into 0.4. Or we can write I is equal to 12 by 0.4. That's equal to 30 ampere. So we got the value of current. So this is a question based on the Ohm's law. Okay. Let us consider the next question. A battery of EMF 10 volt and internal resistance 3 ohm is connected to a resistor. If the current in the circuit is 0.5 ampere, what is the resistance of the resistor? Okay, first thing we have to find the resistance of the resistor. Then second one, what is the terminal voltage of the battery when the circuit is closed? So here we have to find small r and capital V. These are the two things we have to find in this question. I think you guys remember the equation for internal resistance that we derived in our previous sessions. So what is the equation for internal resistance? Do you remember that one? Or what is the relation between EMF, potential current and internal resistance? So the equation was E is equal to V plus IR. So where E is the EMF of the cell, V is the potential in the circuit, I is the current and R is the resistance, internal resistance. Okay. So that was our equation, or we can write I into R plus R also. E is equal to I into R plus R. That also we have the equation. Okay. Yeah. So we have the different equations by substituting the Ohm's law here. Yeah. So now let us look at our question. I know already you read that question. A battery of EMF 10 volt and internal resistance 3 ohm is connected to a resistor. So the EMF is given. What is the EMF given here? E is equal to 10 volt and internal resistance small r is given, that is 3 ohm. That is also given here. If the current in the circuit is 0.5 ampere, so I is equal to 0.5 ampere. Then we are asked to find the resistance of the circuit. Okay. And also second part, what is the terminal voltage of the battery when the circuit is closed? That is, we have to find V also. So we have to find two unknowns here. So first let's find the capital R using this equation. Okay. So in this equation we can substitute the values. What we got, 10 is equal to 0.5 into R plus 3, or from here we can write R plus 3 is equal to 10 by 0.5. Okay, that is equal to 20. Or R is equal to 20 minus 3, that is equal to 17 ohm. So we got the internal resistance. Okay, sorry, resistance of the circuit. Once we got the resistance of the circuit, we can use the ohms law. V is equal to I R. We know the I is 0.5 into R is 17. So what is V? 0.5 into 7 is equal to 8.5 volt. So that is the potential in the circuit. Okay, clear? So next question, at room temperature, that is 27 degrees Celsius, the resistance of a heating element is 100 ohm. What is the temperature of the element if the resistance is found to be 170 ohm or 117 ohm? Given that the temperature coefficient of the material of the resistor is 1.7 into 10 raised to minus 4 per degree Celsius. That means alpha is given. So I think you guys remember the equation for alpha. Okay. So what all things are given in the question? So the temperature, first temperature, that is room temperature. T1 is given 27 degrees Celsius, and initial resistance R1 is given, that is 100 ohm, and the final resistance after the increase in temperature R2 is also given 117 ohm, and the alpha, the coefficient of the temperature, is also given, that is 1.7 into 10 raised to minus 4 per degree Celsius. And we have the equation R2 is equal to R1 into 1 plus alpha into delta T. Delta T means change in temperature. Okay, so delta T we can write as T2 minus T1 also we can write. Okay, or from here we can write delta T is equal to, what we can write from here, we can write delta T is equal to R2 minus R1 by R1 alpha. We can write that like that. So let us substitute the values. 117, that is second resistance or final resistance, minus initial resistance divided by initial resistance into temperature coefficient, that is 1.7 into 10 raised to minus 4. This 10 raised to minus 4 go up and it becomes 10 raised to 4. Okay, yeah, on substituting the values, what we got, this 1.7 into 100, that becomes 170, and this became 70. Okay, that is equal to 17 into 10 raised to 4 by 170, or this becomes 1000 degrees Celsius. That is the increase in temperature. So what is T2? T2 is equal to T1 plus the change in temperature. That is, we know T1 is 27 plus this 1000. What we got? The final temperature is 1027 degree Celsius. That's the final temperature. Next question, that is a very simple question. A negligibly small current is passed through a wire of length 15 meters. So length is given. And the uniform cross section 6 into 10 raised to minus 7 meters squared. And its resistance is measured to be 5 ohm. What is the resistivity of the material at the temperature of the experiment? So here, please note that in this question, the temperature is maintained constant. There is no change. And what all things are given? In the question given, that length is given, area of cross section is given, resistance of the wire is given. We are asked to find the specific resistivity or the resistivity of the material. Now let's consider our third question. A negligibly small current is passed through a wire of length 15 meter. So that length is given. L is equal to 15 meter. And the uniform cross section 6 into 10 raised to minus 7 meters square. So area is also given. Okay. And the resistance R is also given, that is 5 ohm. Then what is the resistivity of the material at that temperature? So we have to find rho. So what is the equation for rho? Rho is equal to RA by N. Okay. Just substitute the values. So rest you have to do. I am not solving the rest of the part. You have to solve the rest. That is your homework part. You have to send it back to me. Next question is from the topic meter bridge or Wheatstone bridge. It has three parts. In a meter bridge, the balance point is found to be 39.5 centimeter from the end A. You can see from the picture. When the resistor Y is of 12.5 ohm, determine the resistance of X. Why are the connection between resistors in a Wheatstone bridge or meter bridge made of thick copper wires? Second B part, determine the balance point of the bridge if X and Y are interchanged. And the third part, what happens if the galvanometer and the cell are interchanged at the balance point of the bridge? Would the galvanometer show any current? These are the three parts of the question. Let's discuss one by one. In this question, what are things are given? So I am reading the question. In a meter bridge, the balance point is found to be 39.5. That is, we got L is equal to 39.5. So if we have L, then we have to find 100 minus L also. 100 minus L is 60.5. 60.5. Okay. When the resistor Y is of 12.5 ohm, that is, there is a resistor Y. In our equation we wrote R. Do you remember that equation? Yeah. Instead of R in the question it is given that Y. So you can see it from the figure. So Y is given. Okay. So what is Y? Well, Y is 12.5 ohm. Okay. Determine the resistance X. So we have to find the resistance X. Okay. So what is our equation? So from the figure, it is clearly understood that this L is proportional to X because L is measured from A. L is measured from A. So we can understand that. I'll just go back to refer that picture. Okay. So L is measured from A. So we can write proportionality X by Y is equal to 39.5 by 60.5. Clear? 39.5 by 60.5. Or from here we can write X is equal to 39.5 by 60.5 into 12.5. Okay. So on solving this, we got the value as 8.16 ohm. So the first part of our question is over. Okay. Now we are coming to our second question. Instead of so our second question, if A and X and Y are interchanged, that means Y comes here and X comes here. Then again we have to find the balance length. Okay. So now we know the value of X and Y. So now let's move on. Okay. So we can take again the same equation, X by Y is equal to, instead of L, we can take another measure, that is we can take L dash. Now it is the measure is taken from the direction of Y because Y is here. So L dash by 100 minus L dash. That's the equation. Okay. So we have to find this L dash. Why I write L dash? Because we already take the L there for the previous one. So now we know the X, value of X. Now we know the value of Y. Okay. So how can you find? Okay. So let's substitute the value 8.16 by 12.5 is equal to 100 minus L dash by L dash. Okay. So on simplifying and solving, we got the value of L dash is equal to 60.5 centimeter. That is same as the 100 minus L of the previous one. Okay. And we are coming to the third question. What happens if the galvanometer and cell are interchanged at the balance point of the bridge? That is, we place a cell here and we place a galvanometer here. Then what happens? That is our question. Okay. So if we interchange, current will start flowing through this one. No current will flow through this way. So what happened? Galvanometer will show zero deflection. So that means there is no current flow through the galvanometer. Clear?